Hi guys, John here for Ham4Ham. I've been working on the different models, optimizing the software and starting to get some of the stuff that's going here that's going to be more important later on. I extended the dipole model to have a couple of different leg options just for testing purposes here. Allowing a height above ground and a certain area to work in and testing it there. Then I went further into speeding up the way the original software works, optimizing the library timings, streamlining it, and also automatic error correction for some of the segment sizes, which could frequently come up. If you look at the graph here on the upper left, you can see that it was changing the segment sizes based on the number of segments per wire, based on the number of sizes. Now, over this last weekend, I started to really jump into forming a cube matrix, three-dimensional, with the length, width, and the height, and just placing random points. And you see on the bottom middle of the screen here an SWR graph. As it evolves it'll try and add a point basically and take it away if it's no good. If it's good, it leaves it in, and it goes and it targets the SWR that you want, and then it goes through it again and removes the points which are non-affecting to the SWR, so basically creating a resonant condition first. Is it practical? No. I'm using this right now to do basically thousands and thousands of calculations to make sure everything is working correctly first, and then building from there. This video is recorded in real time, so what you see is what is actually being processed on the computer. When there's not so many segments, of course, it can go much faster and does slow down. Keep in mind here, I am still running it under the debugger, so there is a performance penalty there for the mathematical functions. And you'll see it continue to build here and target the SWR. You can see on the bottom the resistive component and the reactive component, how that changes as it plays around with the different segments. What I want to add later, of course, is shapes, just shapes that people would standardly use, squares, circles, delta configurations. Also add in the standard models from known antennas and continue there. Once it's through this segment of it where it's stripping away the points of the segments that don't affect the SWR, next we'll transition into optimizing. And here's the radiation patterns coming up. I do notice on the right hand side of the screen the blue and the red pattern on the bottom. They don't go with the actual radiation pattern of the antenna, and that's something I think that's in the original software, so that has to be corrected. But you'll see just placing and removing segments makes a difference in the direction, and that's what we'll go for next, and we'll see you next time.